Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy. Today we're going to have a look at the science of flat Earth. So what we have here is a fish tank filled with water, and it's got a layer of a dye that floats to the surface of that water, so you can clearly see where the surface is. And as you see here, this nice smiley face is bendy water. Now, if you actually do a mathematical equation and compare the forces of gravity and the forces of centrifugal force, you reproduce this parabola. So when we do it in real life, it matches the mathematics. Now here's another very interesting aspect to this experiment. Without rotation, the water is all at an equal gravitational potential at the top of the tank here. Every point on this is the same distance to the center of the Earth. And as you see, because the Earth's curve is extremely gentle due to the size of the Earth, this appears to be flat. The fish have swim bladders, and as you see, they are oriented directly to the up and down force of gravity. Notice that they're all horizontal. There's no fish, other than perhaps this one who's diving, that are floating at a different orientation. Now, what would happen if we started rotating this tank and added an outward force in addition to the force of gravity? The prediction would be that the water would heap up on the outer ends. It would sink down in the middle. Fish directly in the middle of the tank will remain in this orientation, but fish in the outer portion of the tank will orient themselves to the direction of force, which will be down in this direction. As a result, the fish will orient perpendicular to it. So let's go see what happens. And again, the reason that the water on the fish tank is curved is that the level of this water is at the same gravitational and force potential at all points. Now, the interesting thing is if you were floating a ping pong ball right here, based on this principle, the ping pong ball would stay right here. It would not roll down here or fall up here. The summation of the forces acting on the ping pong ball right here mean that this spot is no more favorable than this spot for that ping pong ball. There is no force directing it to move downward. It will stay right where the forces are balanced. Now, as you can see very clearly in this image, look at the orientation of these fish. Look at the orientation of these fish. These fish are perpendicular to the vector of gravity because that's the vector that's acting through here. Out here, you have the vector of gravity plus the centrifugal force. The resulting vector is that way, and the fish are located perpendicular to it. By understanding that the surface of the water is the response to the forces acting upon the water, you can see how the water will indeed curve to follow the surface of the Earth and maintain an equal distance to the center of the Earth and an equal gravitational potential along its surface. So the next time somebody asks you to show them bendy water, feel free to show them this video. Now, the next thing that we have to address is the model of the spherical and the flat Earth. In order to understand our environment, we have to have some way of modeling that environment so that we can make some sense out of it. Now, the model that we're going to use today for the spherical Earth is Google Earth. It's a very useful model. We can do a number of things with it. For example, we can navigate. If we were, for example, to start out here in South Carolina, we could plot a course directly across the country out to California. That's in the vicinity of San Francisco. Now, an interesting thing about dealing with a spherical model is when your course is directly in the center of the model, as you can see, it is a straight line. However, if you tilt it down at all, you'll see that it forms what's called a great circle course. It follows the curved surface of the Earth, and it is the shortest distance between any 2 points on the Earth. Now, this is very apparent when you take a spherical object such as the Earth and try and project an image of its surface onto a flat two-dimensional map. Now, what I've done here is gone to flight planning software from something called SkyVector. And I've plotted a flight from Miami, Florida, to Anchorage, Alaska, over to Greenland, and back down to Miami. So even though these magenta lines are the shortest distance between those 2 points, you can see on the surface of the Earth they curve significantly due to the fact that they are following what's called great circle courses rather than a straight line from point A to point B. This is actually longer than this line would be. Now, for example, taking that last course from Greenland down to Miami, or Fort Lauderdale as the case may be, you can clearly see that that line is curved. But is that indeed a straight line on the surface of the Earth? Let's have a look. Yes, it is. And as you can see, that straight line is the shortest distance between Greenland and Miami. But because it's drawn on a curved surface, it actually curves. It follows what's called a great circle course. For many years, we have asked the Flat Earth to present us with some sort of a model of their flat Earth that is A, as useful as our model of the globe Earth, and B, can be tested. For years, they refused, preferring instead just to argue that the Earth is not a sphere without presenting any evidence whatsoever that it was indeed flat or any other shape for that matter. But finally, we got one prominent Flat Earther Gleem to present the model of the flat Earth. Let's have a look at that. Now, this map of the flat Earth is very interesting because it has a number of testable things on it. Let's go over a couple of them. First of all, let's identify a few things. This is the North Pole right here. And this is Upper Canada and the polar ice packs. We obviously have the continents. Here's North America, here's South America, we have Asia, we have Europe and Africa. And down here is Australia. Now, there are a couple of other things that are very interesting. One is MCMURDO Antarctic Base, which is indeed on the coast of Antarctica. And they do acknowledge the fact that it exists. They also have the Scott Antarctic Base, which is at the South Pole. It is nowhere near the coast. But hey, who's looking at details? Second of all, they have the Southern Magnetic Pole out here off the coast of California. It, of course, isn't located here, but we're going to run with that for a few minutes. Now, something that I'd like to point out is this dotted line is the equator. And even though that's not a circle, which is what it should be, we're going to kind of go with it because, hey, we're flexible. Now, associated with the equator are two tropics. 23.5 degrees north of the equator towards the North Pole is the Tropic of Cancer. And 23.5 degrees south of the equator towards, I guess, the ice wall out here is the Tropic of Capricorn. Now, those are two very important points. You can have a look at the equator here. If you look at the circumference of the circle, the circumference of the Tropic of Cancer, which is within the equator, will be smaller than the circumference of the equator. The Tropic of Capricorn, which is located outside of the equator, away from the pole, will be considerably larger than the equator. Now, what I want to call your attention to is this purple line. There is a race that is held every few years that's based in France called the Vendée Yacht Race, and it is a quote-unquote around-the-globe race. The blue line here, off the coast of the ice wall, or as we call it, Antarctica, is the course of the race. They're trying to change the course of the race to this purple line. And I guess you could sit down and make an argument for that. The race is starting in France. It's going around the southern tip of Africa. It's going around Australia, the southern tip of Australia, and also around the southern tip of South America. It should be noted that all of these points, Africa, South America, and Australia, are well beyond the Tropic of Capricorn. So this purple circle, by definition, must be larger than the Tropic of Capricorn. More on that in a few minutes. Now, one other thing that I want to touch on is the numbers that Gleem provided for this flat Earth map. The distance from the North Pole to the ice wall is 6214 miles. almost 10,000 kilometers. The sun is 40 miles in diameter and located 4,000 miles above the surface to the Earth. Here's the meat and potatoes of this, though. The circumference of the Tropic of Cancer is listed here as 28,928 feet. Now, mind you, the circumference of the equator is less than this. It's actually 24,901 miles. The circumference of the Tropic of Capricorn is listed at nearly 50,000 miles. Now, there's a couple of interesting things about the sun speed here. First of all, when the sun is following the Tropic of Cancer in the northern hemisphere, its hourly speed is going to be 1,205 miles an hour. However, to keep up with the 15 degrees per hour drift, thank you, Bob, down at the Tropic of Capricorn, it's got to speed up to over 2,000 miles an hour. I would very much like to know what speeds the sun up from 1,200 miles an hour to 2,000 miles an hour. But let's go back to the circumferences of the Tropic of Cancer, and especially the Tropic of Capricorn. Recall that the Tropic of Cancer is within the equator. The Tropic of Capricorn is outside of the equator, but it is clearly north of the tip of South America, the tip of Africa, and the tip of Australia. According to the Flat Earthers, the Vendée yacht race is this purple line which goes outside of those 3 points. So by definition, it is larger than the 50,000 mile of the Tropic of Capricorn. But the race is a known distance of 30,000 miles. So rather than let the facts get in their way, they'll just mark this as 30,000 miles. So how are we going to go from 28,000 miles to 25,000 miles to 50,000 miles and then back to 30,000 miles? Let's have a look at the Vendée yacht race real quick. Now, you can go to Vendée Globe, that's a big hint, .org. Now, the Vendée yacht race itself is a race around the globe. You can read about it here. Here are the people that have actually done it, so you have individuals that you can look to for more information. Here are the routes that were taken. Let's go ahead and zoom that out a little bit. So as you see, it looks like it starts up here in France. It goes around Antarctica and returns to France. And as you can see on this particular yacht, the race time was 80 days, 13 hours, 59 minutes, and 46 seconds. Its travel distance was 24,500 nautical miles. And there are the average speeds. Notice that they acknowledge the presence of MCMURDO and Scott Antarctic bases. So they do believe that these are real places. So here we have MCMURDO Station in Antarctica. Now here is the actual location of MCMURDO Station. 77, almost 78 degrees south and 166 degrees east. And in December, there's a 24-hour sun. Now here's the data from the sun. It's due north at exactly 1:51 p.m. And here's the angle, 36 degrees. And at 01:51 local time, it's at an angle of 11 degrees, and it is due south. And this is December 21st, 2020. By going to MCMURDO here is the direction of the sun. Now, the interesting thing about it is these point towards the north, and on the opposite side, they point towards the south. Notice the path of the sun. Let's see what the Flat Earth says about the location of the sun. Well, here's our Flat Earth map. And as you can see, it's very similar to the one that I put out. Here's the equator. Here is the Tropic of Capricorn and the Tropic of Cancer. At all times on the flat Earth, the sun is between these two tropics. There is no time that the sun is directly over any part of the Earth that is outside of these tropics. How do you reconcile these vectors? Where is the sun when this is the direction to the sun? MCMURDO is here, and the Tropic of Capricorn is all the way up here. At all times, the sun would have to be north of McMurdo Antarctic Base. So that pretty much rules out this concept that the sun always stays up here on a flat Earth, because we can physically measure it in other locations. Let's go ahead and fold this in and see how it works on a globe Earth. That's the due north. That's the due south. It's kind of strange. The sun always looks like it's going in the same direction, and night and day seems to add up with the sun out in that direction. That's an inconvenient truth, Flat Earth. Thanks to Joe's Lays for this animation. He does great work. Stop by and check out his channel. Okay, so once again, here's McMurdo Station on our flat Earth map. The direction towards the North Pole would be north. South would be away from north, out in this area. Now, they already have enough problems trying to figure out night and day on a flat Earth. Try and figure out what would happen if the sun was out in this direction. Would this entire Earth be in darkness? Does that ever occur? We have lines of longitude that start at the North Pole and extend outward in a radial fashion. As you go south, which is the direction away from the North Pole in any direction, on a flat Earth, those lines of longitude will become farther and farther apart, reaching their maximum all the way out here in the ice wall. Is this actually the case on the globe? Well, let's see. The equator on a globe is approximately here. And as you see, that is the widest point on the spherical Earth. The Tropic of Cancer is up here. That is narrower than the equator would be. Likewise, the Tropic of Capricorn would be down here, and the circumference of the Tropic of Capricorn is smaller than the circumference of the equator for the same reason. On a flat Earth, lines of longitude will be the closest together at the North Pole, and they will continue to expand out as you move south. Lines of latitude on both the flat Earth and the spherical Earth would remain the same distance apart, but these lines of longitude will definitely show changes based on how far you are from the pole and where you are in relationship to the equator. Let's go out and test this. Where's Wally recently did an excellent presentation on this, and what he used to determine differences between lines of longitude, which are the lines that go north-south, was he looked at airports that had east-west runways, both in the northern hemisphere, near the equator, and down in the southern hemisphere. Now, once again, on a globe Earth model, the runways with the longest interval between longitude will be down here on the equator. As you come up to North America, they will be shorter. If you go down to South America, they will also shorten compared to the equator. On a flat Earth, by definition, the difference between the lines of longitude will be the shortest in the northern hemisphere, they will be longer at the equator, and they will be longest in the southern hemisphere. Let's see what the actual results turned out to be. So here is one of the main plots from his video. This is a plot of the number of kilometers per degree of latitude. At different latitudes, going from the far south to the far north, you'll see that approximately 111 kilometers equal 1 degree of latitude. So you see this nice line right here. Now, there are some outliers out here. And just to clarify a few things, those outliers are due to the way runways are actually designated. Runways are designated according to magnetic rather than true north heading. And the other thing is, you see how he's got runways from 170 to 190 degrees? So the thing is, not every one of these runways is exactly north and south. When you tilt the runway in relationship to the true north-south geographically, you actually change the length, and that has to do with the cosine of the deviation. So you're going to get some minor variations because these runways, instead of being straight up and down, are actually a little bit off to the side. Now let's compare this to the number of kilometers per degree of longitude. Now before we do that, let's go ahead and just have a look and see how it was measured. This is an east-west runway right here. The length of this runway is surveyed. And when you get into the data of the airport, the latitude and longitude of both ends of the runway is carefully measured. Now, this is measured generally by GPS data because that's accurate to within a meter or so and very convenient. You can survey it with a sextant, but more importantly, if you look at the navigation equipment of aircraft, they use what's called an INS for navigation. That INS is built on 3 laser ring gyros or fiber optic gyros. They are independent of GPS and the sun. They simply measure your actual position in space. Those INS units will be programmed to go directly to the latitude and longitude that is reported for the end of the runway. So without seeing outside, without looking at the sun or the stars, the aircraft knows where it is, and if it's told to land on this runway, it goes to exactly this coordinate. That verifies the fact that that coordinate is correct independently. So this is not a function of the accuracy of GPS or how GPS works. It's a function of the coordinates on both ends of the runway. If those coordinates were not correct, the plane would not be able to find the particular spot in space that represents the very end of that runway so that the plane could land. Here are the airports that Where's Wally evaluated and incorporated in his spreadsheet. As you see, they go from the far north all the way down to the far south, and there are many on the equator as well. So once again, looking at the data, this is the distance between lines of latitude going north-south. Nice flat line. If we look at the number of kilometers per degree of longitude, up here in the far north, it is short. It peaks at the equator. And then most importantly, as it goes south, it shortens again. This is completely inconsistent with the flat Earth model, where you would see a line going from the shortest at the north, going up to the equator, and then continuing to increase the further south you went. This is only consistent with a globe. Now, I've put a link to Where's Wally's video in the description, and in his description on that video, he has got his full data set if you would like to run these numbers yourself. That's another difference between globe Earth and flat Earth. We don't have a problem putting out our numbers and letting you verify them yourself. You can also go to flight planning software on the internet and verifying the data points for yourself from the primary source. Now, the problem that we run into with the flat Earth is trying to get them to acknowledge actual evidence. They're very happy to go talking about domes and claiming that the sun is 40 miles in diameter and only 4,000 miles in elevation. Even though shooting the sun with a sextant doesn't agree with those numbers, they will maintain it to the death. When you present them with evidence like this, they will find all sorts of excuses. One that I've heard already is, well, we can't rely on any of this because it's GPS. Well, I've just shown how we can independently verify the latitude and longitude without respect to how that latitude and longitude was obtained, and that is with the navigation systems of planes. Let's take a quick look at classic flat Earth denial of evidence. Now let's have a look at a video that was put out by a minor flat earther not long ago. The title is "The Doctor is Bobbed." Apparently that was some sort of a dig against me. And this is a photograph that I took last fall, I believe it was. This is the highway near my home. I was on my way home from work. I happened to notice this sunset. I realized the significance of it, and I took a quick picture. Now the sun had just set below the horizon here in the west. So the sun is below the curve of the earth right now. There is no sun visible in this picture. What is visible is a bunch of high altitude clouds, which are underlit by the sun, which again is below the horizon. And these low clouds right here are in darkness. And as you see, they're completely gray. So again, high altitude clouds lit up by the sun. Sun is below the horizon. Lower clouds are in darkness. Now, you do have a little bit of reflected light from this very bright sky, which you can see on some of the clouds right here. But these clouds are definitely in darkness compared to these up here. Let's see how this gentleman, who claims to have been trained as an artist, is trying to interpret this very same picture. Now, mind you, I watched the sunset, and that was reported to this gentleman. He was aware of that. Here's the underlit clouds. Now he's claiming that there is a underlit part of this cloud and that is the sun. The sun is down here. The sun has already set. That's just a light-colored cloud, and it's exactly like many other light-colored clouds in the area. It just happens to be in the vicinity of where the sun set. But let's look at this one right here. He's claiming that this cloud is lit underneath. Notice he doesn't mention anything about these clouds over here, okay? Let's go ahead and look back for a second. Is that cloud lit underneath like these? I think not. Now let's have a look at another classic example of that. This one was off the internet. These are two lenticular clouds above a mountain. Notice that the top of the cloud is dark in both cases, and this top cloud is underlit by the sun. Notice that there is another cloud directly underneath it. So that sunlight is not coming up through that cloud here. That sunlight is coming in from this direction. The sun is located below this cloud and a little bit below this cloud. So you see the lower aspects of this are being lit from the sun, which is out here. But in both cases, both clouds are dark on the top. Let's see what Mr. Artist had to say about this. So again, he's saying that the very edge of this cloud is lit up, as it should be, because the sun's coming from out here. He doesn't address the fact the top of the cloud is dark, or the top of this cloud is dark, or the only way for sunlight to get into this area is to come in from the side between these cloud layers. The sun is indeed between these cloud layers because even though you get the very lowest aspect of this cloud down here lit up, notice the center part of the cloud, which is a little bit higher, is in darkness as well. So there's a very good indication of where the sun's coming from. This is not recognizing what this photo shows, and this is outright falsification of evidence. That is not the sun. That cloud is not sunlit underneath. He's just drawn a circle around it and claimed that it was. Now, if you had any doubt that the flat earth had a very marginal understanding of the science, let me hold this up as an example. This is a demonstration of how we know that the light coming from the sun arrives at Earth in parallel. Notice that we're holding up a stick with a ball on it, and that round surface has got a phase to it from sunlight. It's being held up and directly compared against the moon, which shows the same phase. Here's a different phase on the ball, and again, it matches the phase of the moon. I almost hesitated to show this. This is his ball. Where's the moon? Where is the sun? What could he hope to possibly demonstrate with this? A regular wad of clay. And as he moves this little wad of clay, it's absolutely no surprise the phase on the wad of clay changes. It should be noted that neither of these shots of this irregular lump of clay are in focus. Okay, so what's he trying to show here? Do you see any phase at all on this wad of clay? I don't. Now, the final thing is compare the phases of the moon here. They're extremely clear. That's the phase he was going to try and work with right there. And he wasn't even using a spherical surface. He was using a lump of clay that was roughly reminiscent of a potato. So the bottom line is this: flat Earth is not a scientific endeavor. Flat Earth is not even a scientific theory. It's basically a narrative that can be whatever they want it to be because they're making it up as they go. This map is nothing compared to reality. It's easily testable to show that it is not related to reality. These numbers, the sun's speed does not depend on whether it's over the Tropic of Cancer or the Tropic of Capricorn. It certainly doesn't nearly double for unknown reasons. The fact that the circumference of both tropics is shorter than that of the equator is very easy to verify using surveyed runway lengths throughout the world. And finally, in order to try and make the flat Earth model fit in to observed reality, you have to have another excuse as to why the sun is not up between the tropics. I wait with bated breath to see how the flat Earth explains this. This is Bob the Science Guy. Thank you very much for stopping by and visiting with me today. as we destroy the evidence of the flat Earth yet again. Stop by and have a look at Joe Slay's and Where's Wally? The links are in the descriptions. If you like what you see, drop him a subscription and say hi from Bob the Science Guy. Take care and thank you for your support of this channel.
Mama, please make them hear me, or I can't teach them anymore. This rabbit hole's too deep for me. Feel my brain getting real sore. Bob the Science Guy. Bob the Science Guy.